With this video, we're going to be starting Unit 10. Unit 10 deals with trig equations and identities. It's my favorite unit of the year because it actually pulls together all the algebra and all the trig all in one unit. Alright, so we need to talk a little bit about how trig deals with algebra. So it says algebraic techniques and trig expressions. You want to treat your trig functions like sine of theta, cosine of theta, tangent of theta, or even sine of x, cosine of x, etc. the same way you would a variable. So anytime you would see sine of theta, it's like an x or a y or a z. It would stand for a letter. And remember, in algebra, x and y are not like terms, so therefore your sine of theta and your cosine of theta cannot be like terms. It would be like having two different variables. Here's a note, something that you really want to take special attention to. Sine squared of theta means you're going to actually take the sine of x and actually square it, which means sine of x times sine of x. Sine squared of x does not mean take sine and just square the x, okay? Because basically what they're saying here is you're squaring the sine value, and sine of x squared means you're just squaring the x value. So be very careful about that because that's very important. All right, let's take a look at our two examples on what I want you to do. Algebraic expressions. The actual directions are saying here that they want you to factor completely. Okay, so first method of factoring is always GCF. And if you still have a squaring left over, you want to go to two binomials. Well, in 1a, we're actually going to factor using GCF. I'm going to pull out an x, and then I'm going to get x plus 1. I no longer have a squaring, so I'm done. So let's take a look at 1b. Sine squared of theta plus sine of theta. Well, it looks like I can also GCF out a sine. So if I GCF out a sine of theta, I will have sine of theta plus 1. So I'm actually thinking of sine of theta as an x. All right, let's go on to a couple more examples. X squared minus y squared. I can't GCF, but they both are squaring. It's dot. So it's going to be an x plus a y and an x minus a y. Well, let's see how dots relates now to trig. Sine squared of theta minus cosine squared of theta. I have two squared terms separated by a subtraction. So it's going to be sine of theta plus cosine of theta times sine of theta minus cosine of theta. So basically we're again treating sine of theta and cosine of theta like two separate variables. Alright, 3a. I can't GCF, it's not dot, so it looks like it's backwards FOIL. So I'm going to set up my two binomials. It's an x and an x. Factors of a positive 2 will give me a negative 3. You're correct, negative 2, negative 1. Alright, now let's look at something like that in terms of trig. Tangent squared of theta minus 3 tan of theta plus 2. Basically, if we think of tan of theta as an x, it's really like we have x squared minus 3x plus 2, which is kind of exactly what we had in 3a. So if we can factor it the exact same way we did 3a, so we're going to set up our two binomials, and we're going to end up with tan of theta and a tan of theta, because that'll give us tan squared of theta. Factors of a positive 2 will give me a negative 3. It's going to be a minus 2 and a minus 1. So that's how you actually factor trig functions. Alright, they want us to simplify. Remember, the object of the game to simplify is to factor and cancel as much as you can. Alright, so on the top I have 2 cosine squared of theta. The only thing I can do is factor that out to be 2 cosine of x times cosine of x. There's nothing more I can do because there's no addition or subtraction signs. On the bottom, there's really nothing I can do, so I'm going to bring it down as 2 sine of x cosine of x. I can't GCF or go to two binomials. Alright, it's all multiplication, so is there anything I can cancel? Oh, I can go a 2 for a 2, and I can go a cosine for a cosine. So let's see, what do I have? I have cosine of x on the top, and I have sine of x. Now, can I simplify that even more thinking of trig terms? What's cosine over sine? Oh, hopefully somebody said cotangent, so it's cotangent of x. That's my final answer. So the object is to actually get everything down to sine and cosine as much as you can so you can cancel, and then simplify it even more if you can rename it. All right, let's take a look at number 5. I actually can't factor anything because I'm actually adding a fraction to a whole number. So I'm going to make 1 a fraction by putting it over 1. Common denominator for cosine squared of theta and 1 would be cosine squared of theta. Okay. Whoops. So this is going to stay a sine of theta, sorry. And what did I multiply 1 by to get cosine squared of theta? Cosine squared of theta. So cosine squared of theta times 1 is cosine squared of theta. When I add fractions, I bring over 1 common denominator. And I'm going to add sine of theta plus cosine squared of theta on the top. Now I'm going to ask myself, can I GCF anything on the top? Nope. I really can't do any. I can't cancel a cosine squared of theta for cosine squared of theta because think about that. This is like having x plus y squared over y squared. You can't cancel the y squared because the y squared in the numerator is part of the binomial. It's like chopping off someone's legs for a whole body. So you can't do that. So basically, we can't really do anything with our answer. So that's our answer. All right, let's go on to a couple more. All right, simplifying complex fraction. We know that to simplify a complex fraction, we use the LCD method. So now we're going to do complex fractions with sine and cosine. Well, let's take a look at number 1. Our denominators are cosine of x and cosine of x. So what do you think our LCD is? You're correct. It's going to be cosine of x. So I'm going to multiply every term by cosine of x. So even this 1 by cosine of x, and this by cosine of x. So let's see if I can do any canceling. I can cancel a cosine of x for cosine of x, and a cosine of x for cosine of x. There's nothing else I can cancel. So let's see what I have left on the top. On the top I have sine of x, and on the bottom I have cosine of x times 1 is cosine of x minus sine squared of x. Let's take a look and see what I have. Can I actually factor anything else out? Well, if I'm not sure, I can rewrite it in terms of variables. It would be like an x over y minus x squared. Nope, can't actually cancel anything out, so basically this is my answer. Let's take a look at number 2. My denominators are cosine of theta and sine of theta, so my LCD's got to be cosine of theta and sine of theta. So I'm going to multiply every term by cosine of theta and sine of theta. So this is going to be multiplied by cosine of theta, sine of theta. This term is going to get multiplied by cosine of theta, sine of theta. This guy is going to get multiplied by cosine of theta, sine of theta. And this term is going to get multiplied by cosine of theta, sine of theta. Let's see what I can cancel. I can't cancel anything on the top because the tops do not have any fractions in them. But on the bottom I can go a cosine for a cosine and a sine for a sine. So what do I have left over? Cosine of theta, sine of theta times sine of theta will be cosine of theta times sine squared of theta, because a sine times a sine is a sine squared, plus cosine of theta times cosine of theta sine of theta will be cosine squared of theta times sine of theta. And on the bottom I have sine of theta plus cosine of theta. All right, let's see what I can do. Can I factor anything on the top? Well, it looks like I can GCF out a cosine of theta and a sine of theta from each portion and get sine of theta plus cosine of theta. I can't do anything to the denominator, so I'll just bring it down. Can I cancel like terms? Well, I can actually cancel a sine of theta plus cosine of theta for a sine of theta plus cosine of theta because they're like binomials. So my final answer is going to be cosine of theta times sine of theta. So there you go. We started to actually perform a little bit of algebra using trig functions. If you have any questions, you might want to replay the video to get some more clarity. And if that doesn't help, please bring your questions to class tomorrow. See you then.